When considering demand factors for a commercial kitchen, it's crucial to understand which appliances are classified as kitchen equipment. This classification directly impacts the electrical load calculations, which are essential for ensuring the electrical system can safely and efficiently handle the demands of the kitchen. The National Electrical Code, or NEC, provides guidelines for calculating these loads, specifically in Section 220.20. While the NEC doesn't offer a highly specific definition of kitchen equipment, the general principle is that it encompasses appliances and devices used in the preparation, storage, and service of food. Let's consider two specific examples: an ice cream dipping cabinet and a walk-in cooler or freezer, and determine whether they qualify as kitchen equipment for demand factor purposes. Firstly, let's examine the ice cream dipping cabinet. An ice cream dipping cabinet is indeed considered kitchen equipment. These cabinets are specifically designed and used in commercial kitchens or similar establishments to store and dispense ice cream for immediate consumption. They are not simply storage units, they are integral to the service of a specific food product. Their primary function is to maintain the ice cream at the correct temperature and present it in a way that's accessible for serving customers. Therefore, because of the specialized function within the food service process, an ice cream dipping cabinet falls under the umbrella of kitchen equipment. Secondly, let's discuss the walk-in cooler or freezer. A walk-in cooler or freezer is also classified as kitchen equipment. This type of equipment serves a vital role in the storage of perishable food items requiring cold temperatures to maintain their quality and prevent spoilage. Walk-in coolers and freezers are typically an integral part of a commercial kitchen's operation, used to store ingredients and prepared food items that are intended for on-site preparation and service. Without such cold storage, a commercial kitchen would be unable to maintain an adequate inventory of fresh and safe ingredients. Now, let's discuss the demand factor for kitchen equipment. According to the NEC, the demand factor for commercial kitchen equipment is 100%. This means that when calculating the total demand load for the kitchen, the full load of all kitchen equipment must be taken into account. There is no reduction allowed for the assumption that not all equipment will be operating simultaneously. This is because, in a busy commercial kitchen, it's quite possible that all equipment could be running at the same time during peak hours. Therefore, it is a conservative approach that ensures the electrical system is adequately sized to handle the maximum potential load. For instance, if you have an ice cream dipping cabinet that draws 10 amps at 120 volts and a walk-in cooler that draws 15 amps at 208 volts, you would need to include the full amperage of both these appliances when calculating the total load for the kitchen. This calculation would then inform the selection of appropriate circuit breakers, wiring, and other electrical components. It's also important to note that this 100% demand factor applies to the general category of kitchen equipment, but there may be other specific rules or exceptions that apply to certain types of equipment or certain situations. To ensure compliance with all applicable electrical codes and regulations, it is always recommended to consult with a qualified electrician or a local code official. These professionals have the expertise to interpret the NEC and other codes and apply them correctly to your specific situation. They can also help you to identify any potential safety hazards and ensure that your electrical system is installed and maintained in a safe and reliable manner. In addition to the NEC, there may be other local codes or regulations that apply to commercial kitchens. These codes may have specific requirements for electrical installations, ventilation, fire safety, and other aspects of kitchen design and operation. It is important to be aware of all applicable codes and regulations and to ensure that your kitchen meets all requirements. Furthermore, regular maintenance of kitchen equipment is crucial for ensuring safe and efficient operation. This includes cleaning, inspecting, and repairing equipment as needed. Neglecting maintenance can lead to equipment failure, electrical hazards, and other problems. It is also important to train kitchen staff on the proper use and maintenance of all equipment. Proper training can help to prevent accidents and ensure that equipment is used in a safe and efficient manner. In summary, when calculating the electrical load for a commercial kitchen, it is essential to consider all appliances that fall under the category of kitchen equipment. This includes equipment like ice cream dipping cabinets and walk-in coolers or freezers, both of which are integral to the operation of a commercial kitchen. The demand factor for kitchen equipment is generally 100%, meaning that the full load of all equipment must be included in the load calculation. To ensure compliance with all applicable codes and regulations, it is always recommended to consult with a qualified electrician or code official. They can help you to determine the specific requirements for your kitchen and ensure that your electrical system is safe and reliable. Understanding and applying these principles will help ensure that your commercial kitchen's electrical system is both safe and capable of meeting the demands placed upon it. Remember, proper electrical planning and installation are essential for the safe and efficient operation of any commercial kitchen. Now let's delve a bit deeper into the electrical considerations for these specific pieces of equipment. For an ice cream dipping cabinet, you need to consider not only the running amperage of the compressor motor, which keeps the ice cream frozen, but also any additional electrical components such as lights, heating elements for defrosting, and controls. These all contribute to the total load. It's also important to consider the inrush current of the compressor motor when it starts up. This inrush current can be significantly higher than the running amperage and can place a strain on the electrical system. Therefore, it's important to use circuit breakers and wiring that are properly sized to handle this inrush current. Similarly, for walk-in coolers and freezers, the electrical load is determined by the compressor motor, as well as any fans, lights, and controls. Walk-in units often have larger compressors than smaller reach-in refrigerators, so their electrical demand is typically higher. In addition, walk-in coolers and freezers may have heaters to prevent ice build-up around the door seals. These heaters also contribute to the total load. When installing walk-in coolers and freezers, it's important to follow the manufacturer's instructions carefully. These instructions will specify the correct voltage, amperage, and wiring requirements for the unit. It's also important to ensure that the unit is properly grounded to prevent electrical shock hazards. In addition to the specific electrical requirement of each piece of equipment, it's also important to consider the overall layout of the kitchen and the placement of electrical outlets. Outlets should be located in convenient locations and should be of the appropriate type and amperage for the equipment being used. It's also important to avoid overloading circuits. Overloaded circuits can cause breakers to trip, which can disrupt kitchen operations. In extreme cases, overloaded circuits can cause fires. To prevent overloading circuits, it's important to distribute the electrical load evenly across different circuits. This may involve installing additional circuits to handle the load. It's also important to use power strips or surge protectors with caution. These devices can be useful for plugging in multiple devices, but they can also overload circuits if they are not used properly. When using power strips or surge protectors, it's important to make sure that they are rated for the amperage of the devices being plugged in. It's also important to avoid daisy chaining power strips or surge protectors together, as this can overload the circuit. In addition to these specific considerations, there are also some general electrical safety tips that should be followed in all commercial kitchens. These include keeping electrical cords and outlets dry, avoiding the use of damaged or frayed cords, and never attempting to repair electrical equipment unless you are a qualified electrician. It's also important to have regular electrical inspections performed by a qualified electrician. These inspections can help to identify potential safety hazards and ensure that the electrical system is in good working order. By following these electrical safety tips, you can help to prevent accidents and ensure that your commercial kitchen is a safe place to work. Finally, consider energy efficiency. Commercial kitchens are energy-intensive environments, and energy costs can be a significant expense. Therefore, it's important to choose energy-efficient equipment and to implement energy-saving practices. Energy-efficient appliances can significantly reduce energy consumption. Look for appliances with the Energy Star label. This label indicates that the appliance meets certain energy efficiency standards. Energy-saving practices include turning off equipment when it's not in use, using timers to control lighting and other equipment, and regularly maintaining equipment to ensure that it's operating efficiently. Proper insulation can also help to reduce energy consumption. Make sure that walk-in coolers and freezers are properly insulated to prevent heat loss. Sealing air leaks around doors and windows can also help to reduce energy consumption. Furthermore, consider the use of LED lighting. LED lights are much more energy efficient than traditional incandescent lights. They also last longer, which can save on maintenance costs. Training kitchen staff on energy-saving practices can also help to reduce energy consumption. Make sure that staff members are aware of the importance of turning off equipment when it's not in use and of following other energy-saving practices. In addition to these specific considerations, there are also some general tips for managing energy consumption in a commercial kitchen. These include monitoring energy usage, identifying areas where energy is being wasted, and implementing strategies to reduce energy consumption. By implementing these strategies, you can significantly reduce your energy costs and improve the sustainability of your commercial kitchen. The principles discussed can be directly related to NEC articles. Firstly, Article 220 covers branch circuit, feeder, and service calculations. Specifically, 220.20 addresses kitchen equipment and the demand factors applicable to it. Understanding this article is crucial for accurately calculating the total electrical load of your commercial kitchen. Secondly, Article 430 deals with motors, motor circuits, and controllers. This is highly relevant when considering the electrical requirements of equipment like ice cream dipping cabinet compressors and walk-in cooler/freezer motors. It provides guidelines for overload protection, conductor sizing, and disconnect means. Thirdly, Article 440 focuses on air conditioning and refrigeration equipment. This article is especially important for walk-in coolers and freezers, as it provides specific requirements for the electrical installation of these types of equipment. It covers topics such as disconnecting means, branch circuit protection, and motor compressor overloads. Fourthly, Article 310 pertains to conductors for general wiring. This article is essential for selecting the appropriate size and type of conductors for all electrical circuits in your commercial kitchen. It provides ampacity tables and correction factors to ensure that conductors are properly sized to carry the intended load. Fifthly, Article 250 covers grounding and bonding. Proper grounding and bonding are crucial for electrical safety in any commercial kitchen. This article provides guidelines for grounding electrical equipment and bonding metal parts to prevent electrical shock hazards. Remember, the NEC is a comprehensive document, and it's essential to consult the specific articles and sections that apply to your situation. Consulting with a qualified electrician or code official can help to ensure that your electrical installation complies with all applicable requirements. The NEC is updated regularly, so it's important to use the latest edition. State and local jurisdictions may also have their own amendments or supplements to the NEC, so it's important to check with your local authorities to determine which codes are in effect in your area. Staying up to date on the latest electrical codes and regulations is crucial for ensuring the safety and compliance of your commercial kitchen. By following these codes and regulations, you can help to prevent electrical accidents and ensure that your kitchen is a safe and efficient place to work.